Alright, so the first question asks the mass of the oxygen in the product. You already figured that one out. Let me just erase all this. Alright. The one that you're finding is right here, 0.16, and you took the mass of the product minus the mass of Mg. Here's the mass of the product. Here's mass of Mg. You subtract that with 0.25, and you get 0.16. So, let's write that out. 0.41 minus 0.25 equals 0.16. So this is your, really? That's your answer. Alright. So now we're going to find the empirical formula for magnesium oxygen product. So what we're going to do is we're going to take the grams that you found in your experiment. So we got 0.25, which I know is Mg, and we got this one, which is O. So we're going to take those molar masses, and we're going to find the moles. So you're going to set it up an equation, so you're going to do 0.25 grams of Mg over 1. So you're going to take that, and your molar mass is going to be 24.31 grams over 1, under 1 mole. And you're going to get, let's do it out on the calculator, 0.25 divided by 24.31 equals 0.01028. Okay, that's basically what you get, but for this case, make this smaller, because I don't have any room. Like, no room. So, do this, 0.01028. Alright. So now you're going to take the O, here you go, 0.16 grams of O over 1 times 1 mole over 16 grams, because this is your molar mass of both of them. And you're going to get 0.16 divided by 16. Who is this? So you're going to get 0.01. Someone just called me, and I do not know who it was. Hopefully it wasn't my Pasco E-School teacher, because I am not ready to do that. But anyways, so then what you're going to do is you're going to take these numbers, and you're going to determine which one is the least. So, in this case, it's this one. Correct me if I'm wrong. Yeah. It's that one, because, like, this is going to make me go nuts. Because this one's 0.01028. So, like, that one's a little bit bigger. So, you're going to take this and you're going to go 0.01 divided by 0.01. And they're both going to roughly come out to 1. Don't just do, like, 1.00, like, 2. No. Determine which, like, round it to the nearest whole number. So, then you're just going to get MgO as your answer. Alright, now we are finding the percent composition of Mg, and we are finding the composition of O. And this is to find the formula for magnesium oxide, which we did, but we are going to determine if the formula is correct that we just found out. So we're going to see if they both match up. So you're going to take your grams of Mg and your grams of mole of O. So your grams of Mg is 0.25. Oh my God, why won't it write it? 0.25 over 1 second. Oops, sorry, back it up. Alright, so you know that your mg is 0.25 and your O is 0.16. So you're going to add those together to get the total mass of both of those combined in the formula. So your answer is going to be 0.25 plus 0.16. Oops, I did that wrong. Ugh, these calculators on your phone are annoying. 0.41. So that's going to be your answer. So 0.41. So just remember that. I need room. 0.41 is your total mass. So we're going to put that under. So your answer is going to be 0.25 divided by 0.41. So you're going to get 0.609, which in percent form times that by 100, which will give you 60.9% mg. So now we got to find the O. So you take your 0.16 grams, then you divide that by the total mass, and you get 0.3902. Doesn't matter about those two numbers because, you know, you don't really do it to that much. I don't know how much he wants you to do it. Let's see. Usually it says. It doesn't say anything, so I guess he doesn't really care. As long as they match up, I guess. Which you're going to get 39% of O. And so you can check yourself. That's a percent sign, by the way. It's a percent sign. That's a really bad percent sign. Okay. So 60 plus 39 is roughly about 100. It's basically 99, but you got your 0.9 here, and then you got your 0.02 there. So yeah, it's basically, you could put 0.02, but I just didn't feel like doing it. But you can, because it's your work. I'm sure he doesn't care. Alright, so now what are we finding? Formula for magnesium oxide. So what you're going to do is you're going to take those percent compositions that you just found, and you are going to determine the actual formula with those percent compositions that you found in the experiment. So you are going to take your percent compositions. Correct. Let me make sure I'm doing this right. Alright. So your percent composition is basically a gram. Just treat it as grams. So you're going to do a different color, 60.9, this is mg first, times 1 mole over the mass, which is, 24.31, which will give you whatever. Then you have 39 grams of O. This is mg. Oh my god, it's so annoying. Over 1 mole over 16 grams. Okay. So now you're going to take that and you're going to divide it. .5. Then you have 39 divided by 16. 16, 2.437. So you're going to divide them both by 2.437. So you both get around 1 for each of them. So you're going to get a formula of MgO, which is the same exact formula that you got before. Okay, so next we're going to find number 5. I'm not going to type it out, but it's basically, here, I'll type it. It's just percent error. So you're going to use, will it let me take it? Ah! Whatever. Alright, we're going to deal with that. It's just going to be in the middle of the page. So he gave you your accepted value, which is 60.3, and then you're going to use that value, the value from your number 3 equation, and you're going to put the value from your number 3 equation here, and the value that he gives you on top and bottom, and make sure that absolute value, and here I'll show you. So your result from number 3 for mg is 60.9. So you're going to take 60.9 minus the accepted value that he gave you, which is 60.3. 60.3 absolute value over 60.3. And you know when you do the absolute value that if you get a negative in the absolute value, like -2, the negative doesn't matter, so it's just going to be 2. So in this case, you have 60.9 minus 60.3, which is going to be a positive number, and it's just going to be 0.6. Which is going to be 0.6 over 63, which is going to give you 0.0099, and then times 100, or you could just move the decimal place 2 over to the right, and your answer is going to be 9. So like that. So 1, 2. So your answer is going to be 0.9. Yeah, why can't I do a point? I'll just do it up here. 0.99%. Wow, you did a good job. Your percentage is like, what the heck? You're not even 1%. That's really good. You guys did really good. My percent error when I did this, so I did the exact same thing. Where's it at? Oh, it's over here. My percent error when I did it was 5.24. So you did way better than me in the experiment. So just so you know. And we actually didn't answer all these questions. We answered we didn't answer. You have to answer these. We didn't answer all these. Okay. So then the last question is asking, is your percent mg value too large or too small? What experimental errors might specifically account for this type of deviation? Obviously, your result was 60.9 compared to 60.3. So that means that your value was too large because this is bigger than this. So obviously, you could just write, so I don't remember what you did in the experiment. So you're going to write too large because it's 60.9 is greater than 60.3, which is what the actual value was. And your errors can be like, we didn't wait long enough for the crucible to heat. Maybe like, I don't know what you did. The water didn't evaporate. It just depends on the experiment that you did. I don't know. Just come up with different ways of what didn't happen or what did happen that you think caused it. Like, there was water still left in the crucible when you weighed it, you didn't evaporate all of it. That would count as the mass being too large. You have a little bit left of water in there. Stuff like that. Or maybe you skipped a step. Or just, honestly, just make up something. Because that's what I did.